Okay, let's state and prove Rolle's theorem. Rolle's theorem. Rolle's theorem states if a function f is continuous on closed interval a comma b, if a function is continuous on closed interval a comma b, differentiable on open interval a comma b and fa equal to fv, then there exists a constant c in open interval a comma b such that derivative of f at c, that is your f dash c, is exactly equal to 0. Okay, before going to the proof, let's understand it first. Let's draw x-axis here and y-axis here. We are given fa equal to fv. Let's plot fx along y-axis and x. Now somewhere here, if you have a here and consider the point x equal to a, consider the point x equal to b, then let this point be a comma fa and let this point be b comma fv. Since fa equal to fb, the height must be same. We are given fa equal to fb, the height must be same. Now we are also given that the function is continuous. So I need to draw this kind of whatever be the graph, I need to draw this kind of graph of fx. Graph of fx must be something like that. Not only that f is continuous, but it's also that f is differentiable. That means there is no there is no sharp point anywhere. You cannot draw the graph something like that, which means that you can always draw tangent to the graph at every point. You can always draw tangent to the graph. In such a situation, somewhere you will see that tangent is parallel to x-axis. Now the derivative gives you slope of tangent. F dash x gives you slope of tangent. that f dash x must be exactly 0 at that point. In fact, we are bound to get 3 such points here. Now let us look at the proof. If fx is a constant function, we have first case, the simplest case. If fx is a constant function, that is fx equal to some constant c for all x, every x in closed interval a comma b. Then f dash x equal to 0. Then we have c here, so let me write fx equal to another constant c1, fx equal to c1 for every x in the closed interval. Then f dash x equal to 0. Derivative of constant is 0. Whatever value of x you take. So you can take any x, f dash x equal to 0 for every x in closed interval a comma b. So in this case you have got nothing to prove. Case 2. What if fx is not constant? Well, you have fa here, and you have, when you take x equal to a, you have the graph, and here you take x equal to b, fa and fv, the point a comma fa and b comma fv, they are of same height. Case 2, if fx is not constant, what can we say? Well, there exists a point x0 in closed interval a comma b such that fx0 is greater than fa. Well, it could be that fx0 is less than fa as well. That will do in the case 3. So somewhere here, now fx0 being greater than fa, x0 cannot be a. Somewhere here you have x0 and fx0. So this point is x0 comma fx0, and that is of greater height than fa. Now let's draw any curve. Let's say maybe somewhere it may have any kind of fluctuation, but at least I know that fx0 is greater than fa. Let in such a case, you know that something is bigger than fa. Let theta belong, theta is just a number here, let theta belong to closed interval a comma b such that f theta is the maximum value of fx in closed interval a comma b. What does that mean? Well, whatever be x naught, I don't care, but I know, let's draw it once again. We have x here, x equal to b here, and I know that for x equal to theta, f theta gives us the greatest height. You got to be smooth here. Maybe there is some fluctuation here that we don't care, but I know that this point is the greatest height, that is the maximum. Fx cannot rise beyond f theta. Okay, in such a case, what can we say? Let's calculate the limit. Fx is differentiable, so the following limit must exist. So rather, let's compute. Let's compute now that's limit h tends to 0 f of theta plus h minus f theta by h. That is precisely f dash theta. Can we compute such a quantity? Luckily we can. Let's compute this. So we want to compute limit h tends to 0 f theta plus h minus f theta by h, and that is nothing but f dash theta. We are given that function is differentiable in the open interval a comma b, and we know that theta cannot be a because that's the maximum value. We know that some fx naught is greater than fa. We know that some fx naught is greater than fa. That's the greatest height. So, and that has to be something greater than fa. Should this limit exist? Yes. Then what should be the value of this limit? We are saying let's compute. We can compute. Let's see how. Now when we talk of limit, we have left hand limit and right hand limit. So we draw the graph once again. X equal to a here. We don't care whatever be the shape of the graph, only what we care is, well, f theta is the greatest possible height. And let's draw the other side with the blue color. What we care is that the graph should be smooth. There should not be any, that means we should be able to draw tangent to the graph, or in other words, we should be able to find the derivative. And second point is f theta must be at the greatest point, and f has to be continuous, obviously. X equal to a, x equal to b. Now if this limit exists, theorem says derivative exists, so this limit should exist. What should be the left-hand limit? That means as we take h positive, that is, we want to compute this limit, then compute this. First of all, this limit exists, then limit h tends to 0 plus f of sorry, we are moving from left hand side with black. Let's do h tends to 0 minus f of theta plus h minus f theta by h. That means just look at just move from the left hand side. What can you say about f theta plus h? Somewhere here you have got theta plus h here. If we are moving, when you take h negative, your theta plus h should be towards left hand side, and that must be of less height than f theta. So the numerator should be this is smaller height, this is greater height, so this is smaller than this, so numerator should be negative. What about denominator? Denominator should also be negative because you are taking h negative, so this must be less than or equal to 0, because f theta plus h minus f theta, sorry, this should be f theta plus h minus f theta. F theta is of greater height, yeah, this should be less than or equal to 0, and h is less than or equal to 0. Negative by negative is positive, so this got to be greater than or equal to 0. What about well, limit has to be greater than or equal to 0. What about when I move from the right hand side? Also limit h tends to 0 plus, you are going from right hand side, f of theta plus h minus f theta by h. What can you say about this? If you move from right hand side, again f theta is of greater value than f theta plus h, so numerator is negative, denominator is positive. Once again, numerator, the greatest, f theta is greatest, so this has to be, f theta plus h has to be smaller than f theta, so this quantity, whole quantity, the difference has to be negative, whereas the h is positive. Negative by positive will be negative, because f theta plus h minus f theta is less than or equal to 0. F theta is the greatest value that's possible in that interval, and f theta plus h has to be something less, and if you subtract bigger number from smaller number, you get negative quantity, and in this case h is greater than or equal to 0. So if you take left hand limit, that is, if you move from the left hand side, your derivative has to be greater than or equal to 0. And if you move from right hand side, your derivative has to be less than or equal to 0. Your limit, once again, if you move from left hand side, your derivative or the limit has to be bigger than or equal to 0. If you move from right hand side, your derivative is less than or equal to 0. Why is this happening? Well, numerator is remaining of same sign. Numerator is negative in its case. But denominator is negative in the left hand side limit and denominator is positive in the right hand side limit. Only change in denominator, there is, if you look at these two expression, the only change that you have in term of sign is here your h is negative and here your h is positive. Because h is negative, the ratio is bigger than or equal to 0. Because h is positive, the ratio is less than or equal to 0. But theorem says, well, what does the theorem says? Theorem says limit h tends to 0 plus f of theta plus h minus f theta by h equal to limit h tends to 0 minus f of theta plus h minus f theta by h. These two limits got to be equal. Why? Because theorem says it is differentiable. When the function is differentiable, left hand derivative and right hand derivative both must be equal. Well, if both the derivatives are equal, then what can you say? The left hand derivative must be greater than or equal to 0. Right hand derivative must be less than or equal to 0. So let's combine inequality 1, inequality 2, and the fact that those two limit must be equal. Therefore, by inequality 1 and 2, we have, what do you have? If we combine inequality 1 and 2 and this fact that those two are got to be equal, we have limit h tends to 0. When they are equal, we have left hand derivative and right hand derivative is equal to derivative f of theta plus h minus f theta by h is, well, either it is bigger than or equal to 0 or it is less than or equal to 0. So only choice is it is just a 0. Okay, that goes case 2. Now let's look at case 3 now. Let's just recall. In case 1 we have, well, fx is constant, then you are done. Derivative is 0 throughout, you take any point. In case 2 we have, well, it may be that fx naught is greater than fa, but such a point may not exist. Fx naught is greater than fa, such a point may not exist. Then what can we say? Well, if it happens that such a point may not exist, then since it is not a constant function, fx is not a constant, case 3 we must have that case 3 we must have that there exists an x naught in, call it open integral or closed integral because fx naught cannot be f now. We must have that there exists x naught in this such that fx naught is, if it is not always greater than, then it is less than fa, and that fa is equal to fp as well. Okay, once again, if it is less than, then you should have some minimum because of continuity of function. Then there exist a real number let's write once again theta and let it be capital theta in closed interval, open interval. By this time it must be clear. There exists a real number theta in open interval a comma b such that f theta is maximum of fx, sorry, it is less. If it is less, then let's talk about minimum. Of fx in open interval a comma b. Well, once again, x-axis here, y-axis here, and you have x equal to a here, somewhere here, x equal to b. They are of same height, fa and fb are of same height, a comma fa, a comma fa, and here we have b comma fa. Now you have fx naught is less than fa, somewhere fx naught is less than. When you have less than, let's talk about a minimum. F theta is the minimum possible, that is the least height possible of that function. So somewhere it may fluctuate, but somewhere it should happen that it gets the least value. The function takes the least value, then again it jumps. It may fluctuate, but it acquires the least value. So it coming to x equal to theta, f theta is the least. F theta is the minimum of fx in the open interval a comma b. Now it's clear that theta cannot be a or cannot be b because you have already some x naught such that fx naught is strictly less than fa. Okay, then there exists a real number theta in a comma b such that f theta is minimum of fx in the open interval a comma b. Once again, let's compute the limit. Then limit h tends to 0 minus f of theta plus h minus f theta by h. What can you say about this? Theta plus h slightly it is negative, so somewhere here that's of greater height. F theta plus h is of greater height than f theta, so the difference is positive, h is negative, so this is less than or equal to 0 because f of theta plus h minus f theta plus h is of greater height than f theta, so that is greater than or equal to 0, and h is less than or equal to 0. Positive by negative will give you positive, the ratio will be positive by negative will give you the ratio negative. That negative is in the limiting case maybe 0, so the limit might be less than or equal to 0. Also, let's look at the right hand limit. Let's go from the right hand side. That means h is positive now. Limit h tends to 0 plus f of theta plus h minus f theta by h, that has to be greater than or equal to 0 because f theta plus h is bigger than f theta, so again the numerator remains positive and the denominator also remains positive because h is positive. Now we are taking right hand limit because f theta plus h minus f theta is greater than or equal to 0 and h is greater than or equal to 0. Okay, but function is differentiable, so left hand limit and right hand limit both got to be equal. Limit h tends to 0 minus limit h tends to 0 plus must be equal to f test theta. Since f is differentiable, in open interval a comma b, and theta is in the open interval a comma b, comma, we must have f dash theta equal to, I'm writing capital theta, f dash theta equal to limit h tends to 0 plus right hand limit f of theta plus h minus f theta by h equal to okay, space may not be sufficient, so equal to limit h tends to 0 minus f of theta plus h minus f theta by h. Therefore, by inequality, we have already used inequality 1 and 2. Let's write it as inequality 3 here and inequality 4. Those two limits got to be equal, In one case we have less than or equal to 0, in one case we have greater than or equal to 0, so the only choice is therefore by inequality three and 4, comma, we must have f dash theta equal to in one case less than or equal to 0, in one case greater than or equal to 0, so it is exactly 0. So in each case, in the first case you have, well, for every x in the open interval f dash x has to be 0. In the second case, at the maximum point your f dash theta has to be 0, maximum value of fx. Corresponding to maximum value of fx, theta has to be 0. In the third case, well, corresponding to minimum value of fx, there exists real number theta in such that f theta is minimum, so corresponding to minimum value of fx, you must have f dash theta equal to 0. In each case, you have f dash theta equal to 0, and you have found one such theta. In fact, you have found it that theta corresponds to maximum value of fx or minimum value of fx. Thank you.